Welcome back. In this last section before the first test, we're going to go over the rules of exponents. And there are a lot of different rules that interact with exponents, so we're going to be careful to go over how each of them works. And so in this first video, I'm going to write down each of the rules, and then I'm going to give you an example. So the first rule concerns what happens when you have something like x squared times x to the fourth. And what happens in this case is that you add the exponents, so you end up getting an x to the sixth. And actually, if you want to know why, this one's actually not so bad to see, because what is x squared? It's x times x. And what is x to the fourth? It's x times x times x times x. And so if I just look at this, well, that's 6 x's multiplied together. That's where my x to the sixth comes from. Okay. And so the general rule here is that if you have a to the b times a to the c, that's always the same thing as a to the b plus c. And the reason actually always works the same. Namely, I've got b a's here, c a's here. If I multiply them all together, I have b plus c a's. By the way, all the rules of exponents are written down at the beginning of section 1.3 in the packet, so don't feel obligated to copy them down out of this video. I'm just going over them and reminding you what they are. Now, what's the thing you might have been tempted to do in the previous example? You might have been tempted to multiply the 2 and the 4 and get 8. And you correctly remember that there are times when you multiply the numbers in exponents, but it's not in this situation. The time when you multiply numbers in exponents is when you have what I call stacked exponents, where you have something with an exponent raised to yet another exponent power. In this instance, you multiply them, and so I end up with an x to the 15th power in this instance. Again, it's perfectly fine to ask why. And well, what does x cubed to the 5th really mean? It really means x cubed times x cubed times x cubed times x cubed times x cubed. Okay. And each of these x cubed is 3 x's. So how many x's do I have in total? I have 15 total x's. And so this is this rule. If I have a to the b, and that is raised to the c, that is the same as raising a to the b times c. And of algebra rules, confusing these two rules is probably the most common algebra error I see out of all the algebra rules. So make super sure, and we'll do a lot of practice in this section to make sure that we're comfortable with this, but make super sure that when you have like bases multiplied together, you add the exponents, and then when you have a stacked exponent like this, you multiply the exponents. Okay. What else can happen? Well, you can also end up with numbers to negative powers. So you can end up with something like x to the minus 1, or x to the minus 5. And anytime you have a negative power, what that's telling you is that the thing you're looking at goes in the denominator. So for example, x to the minus 1 is 1 over x. All it does is put the x in the denominator. X to the minus 5, what it does, in fact, is to put an x to the 5th in the denominator. And so the rule here is that if I have an a to the negative b power, that's always going to give you 1 divided by a to the b power. And as a special case of this, as we talked about in the last video on fractions, anytime you see an a to the minus 1 power, that's a 1 over a. occasionally, you'll see something even stranger, namely, you'll see a negative exponent in the denominator. And what that's going to do whenever it pops up is put that thing now in the numerator. Namely, this x squared divided by x to the minus 3, what is it going to be? It's going to be x squared times x cubed, and x squared times x cubed is going to be x to the 5th. And so, just to give you a rule here, 1 over x to the minus a, that's just x to the a. Now, all of this would be well and good, but it gets confused by the fact that we also have fractional exponents. And so we have things like x to the 1/2, or x to the 2/3, and variations of things like this. And so we need to make sure we're comfortable with what these things mean. And in general, I'm going to note as a rule, anytime you have something to the 1/2 power, that is the same as taking the square root. Okay. So negative exponents correspond to fractions. Fractional exponents correspond to roots. Likewise, anytime you have something to the 1/3 power, that's going to give you a cube root. Now, it doesn't come up super often, but because I wrote it here, I want to go ahead and mention what happens if you take something to the 2/3 power. That is the same as doing one of two things. It is the same as taking the cube root of the number and squaring it, or it's also the same as taking the cube root of the number squared. Either of these is an acceptable way of thinking of x to the 2/3 power. So this is just the square root of x, and this is the cube root of x squared. Okay, so just to make sure we're comfortable with all of these rules, I want to go ahead and evaluate some of these powers with numbers, just so that we're comfortable. Okay, so I could, for example, evaluate 2 cubed. And what is 2 cubed going to be? That's 2 times 2 times 2, and that's 8. If someone gives you 9 to the 1/2 power, that's the same thing as the square root of 9. So that is 3. If someone gives you 4 to the minus 1st power, remember the minus puts it in the denominator, so this is the same as 1/4. And we also have combinations. So we have things like 9 to the minus 1/2 power. What is that going to do? That's going to put a 9 to the 1/2 power in the denominator. But 9 to the 1/2 power is the square root of 9. And so 9 to the minus 1/2 power, it's actually 1/3. What about something like 8 to the 1/3 power? Well, this is going to be the cube root of 8. The cube root of 8 is supposed to be the number that if I multiply it by itself 3 times, I get 8. And actually, we saw just a moment ago that that number is 2. And so if you see something like 8 to the 2/3 power, what's that going to be? That is going to be the cube root of 8 squared. The cube root of 8 is 2, so this is 2 squared, and so this is 4. I could also have written this as, instead of being the cube root of 8 all squared, I could have written this as the cube root of 8 squared, but 8 squared is 64, and then the cube root of 64 is in fact 4, because 4 cubed is 64. And so that's what happens with all of these various combinations of exponents. I'll wrap up this video here, but next time we'll go ahead and talk about how we can combine exponents when we're working with variables and manipulating equations. But until next time, be well.